All right. All right, so it's on me to start, isn't it? All right, thank you everyone for coming. I'm really happy to see so many people coming to this. You know, I know it's a 2 o'clock on a Friday afternoon. Probably not the optimal time for a long, in-depth training workshop, but I really appreciate everyone who's coming to this, especially if you went to the NCI data training this morning, which was great. But there was also quite a long workshop. I think it was 4 hours this morning. So if you were there for that and you're here for this, then extra special thank you. We're going to make a start, and I'm going to talk us through a few things. Before we do, I just wanted to do an acknowledgement of country. I acknowledge the traditional owners on the land on which we're meeting. In Melbourne, where a lot of the ACCESS research is done, this is the Boonwurrung people, the Wurundjeri people of the Kulin Nation. I pay my respects to the elders, past and present, and any of the Aboriginal elders of any other communities who may be here today. I wanted to briefly introduce you to the primary staff who are involved in this workshop and who are running. We've got quite a lot of support people in the background. But the main sort of training support, my name is Mackallah. I'm the top on that list. I'm convening this workshop, and I'm also performing the ACCESS-CM2 training, which will happen throughout. I've got in for my CM2 support, I've got Arnold Sullivan here with me, also from CSIRO. Oh yes, I should mention I'm from CSIRO, as you can tell from my t-shirt. We're based in Aspendale in the Climate Science Centre, which is where most of ACCESS is developed from. Along with us from CSIRO, we've got Thilo Zien, who is the main project leader on the ACCESS-ESM project. With Thilo, we've got Holger from CLEX CMS, who will be performing the ESM training around the Payu system. And then also we've got Scott Wales here from CLEX CMS as some general support, helping us run some interference throughout this relatively long training session. We've got 3 hours today. A breakdown of what's going to happen. For the first half hour or so, we've got some introduction. I'm going to talk a bit about ACCESS, the two models, some differences between them, and just sort of a bunch of different things I want to mention before we really get stuck into it. From 2:30 for an hour, we're going to break off into 2 groups. We're going in this main session. I'm going to conduct these ACCESS-CM2 training. At the same time, we're going to have a breakout room going at the same time, in which Holger will conduct some ESM training. This breakout room, it may not be active quite yet, but as of 2:30, you'll be able to select yourselves whether or not to join the ESM breakout room. I hope to get you nice and well informed by the end of this introduction as to which one you might want to join. But just know that that's what's going to happen at 2:30. So we'll be 2 different groups for an hour. From 3:30, we're going to have a half-hour break to just let you go off, get a coffee, tea, whatever you need to do, have a rest. And then from 4 o'clock, we're going to launch back into the second part of our session. I've got half an hour to talk about model output and some post-processing and sort of the once a climate model is run, what do you do with it kind of discussion. That's applicable to both the CM2 and the ESM, so we're going to do that all together in the main session. We're not going to use the breakout room. And then I've allocated about half an hour at the end for some question time. We may or may not get time for some questions in the main breakout sessions prior to 3:30. We'll see if that happens. If it doesn't, we've got lots of time at the end to have some answer some questions and have some chats. A few housekeeping that I wanted to go through before we started. Excuse me. So please keep your microphone muted. I'm happy for you to turn videos on if you prefer. But obviously with this many people, we've currently got 52 people currently in the meeting. Any microphones, additional noise will get very frustrating very quickly. So just keep those muted. If you want to ask a question directly that you would like answered in this Zoom session, feel free to ask them in the chat at any time. We're going to have some people recording down some questions so we can get to them at the end. I've asked you to use a double question mark just at the start of any questions. Nice and obvious that this is a question that you want answered, preferably, or if we have time, obviously. I don't know how many questions we're going to get. And so that's check that in the chat, and we'll get to those. We've also got another an option for asking some questions and some maybe initiating some conversations through the CLEX, the ACCESS Slack channel. I'll introduce those and I'll send some links around later. They're more for just sort of as we go through this training. And last of all, this training is being recorded, I think, in multiple places currently. We're going to record both sessions, the main session and the breakout session. I'll be collating it all probably next week at some point during AMOS, and I'll put it all online, and you'll be able to come back and rewatch these sessions and you know, sort of refer back to them any time if you want. I think that's important for something that is, we don't have a lot of time, online only. We were hoping to do some more interactive work in this workshop, but COVID restricts those kind of activities, and so we will wanted to provide instead something that we can record and then provide later on for you to come back to at any time. I want to say a special thanks to a lot of our sponsors and stakeholders and people who've supported not only this workshop itself, but also ACCESS, the ACCESS work over the last decades, I think, ongoing. In particular, the CLEX, so the Climate Extremes ARC Center of Excellence, which is the collaboration between the universities under CLEX. They've given us a huge amount of help preparing for this workshop in particular, and ongoing. They are an invaluable tool for us to continue ACCESS, both in running ACCESS for next users like yourselves, or even for us in our development stage that we're involved a huge amount, and I just wanted to thank them in particular. NCI for a lot of the comms related to setting up this workshop. And we've got Chris on the line, who you may have seen this morning in the NCI data workshop. I'm really, really thankful to Chris and Jingbo and the whole NCI team for helping us put this together. Not to mention thanking NCI for all of their help throughout all of ACCESS, because that is what obviously we run ACCESS on. We couldn't do this without them. Also wanted to mention the National Environmental Science Program called NEST. NEST 1, the original cycle, first cycle of NEST is just ending. We've got a new one beginning. I've got Simon Marsland here, who I'm going to get to tell us a bit more about it. But first, I just want to also thank the Bureau of Meteorology and CSIRO, in particular the Climate Science Centre, and my team, the coupled modelling team in particular, including Simon, who up to recently was our team leader and captain on the ship of ACCESS modelling. Take it away, Simon.
Thanks very much, Chloe, and welcome everybody. And you know what Chloe was just saying about that list of sponsors and supporters there was really important. Community is the first C in the ACCESS acronym. It is a community model, and we all co-own and co-develop it together. So that's really important to remember that this is a community effort. In terms of the National Environmental Science Program, it's run by Federal Department of Environment. In the Earth Systems and Climate Change Hub, which has been just winding up after 5 years, with very strong support of ACCESS model development for CMIP 6, couple model intercomparison project. First of all, with the climate model version 2, ACCESS-CM2, and in the second half of the Earth System and Climate Change Hub's lifespan, coming in with a lot of support in the ESM1.5 modelling, Earth System modelling phase as well. So that's really been instrumental, and it shows the importance of ACCESS as a climate model is recognised by our federal government, and they conflate CMIP6 with IPCC, Intergovernmental Panel on Climate Change, AR6. So they come to NESP some years back saying, we want an IPCC model, and we give them a CMIP model to serve that purpose, because that is exactly what it is. And delighted that in the new NESP Phase 2, which is just spinning up now, it'll be a 7-year program, 4 hubs, and one of them is the Climate Systems Hub, which I'll be leader of, and that's been announced by Environment Minister Lee last December that we were successful in our consortium. So once again, those 5 same universities in CLEX, BOM, CSIRO, and also state and territory environment departments are all on board for the new NESP 2, and great for ACCESS to see that it was written in scope as one of the priority research areas, so that national capability in climate and earth system modelling is fully supported by the federal department, and that's fantastic. So I want to thank Chloe for stepping up to organise today's workshop, and the other 4 organisers as well for assisting in the running of it and planning for it, which is, you know, a significant amount of work. And welcome potentially some new users at ACCESS, or some people honing their skills on ACCESS amongst the participants today. You're most welcome, and I really hope that, you know, some of you will go on to have modelling as a part of your science career portfolio. So I'll let you go at that. Thanks very much, Chloe.
Thanks, Simon. Yes, I do want to echo what Simon said. I really hope that this training provides a resource to enable a lot of you to consider using ACCESS in your research. I don't have a great view on the range of people who are attending this and sort of knowledge levels, but I'm hoping to maybe send out a survey at the end of this to try and get some of that information. I'll talk more about what this is targeted for, but I'm hoping that out of this, yes, we can have some people using ACCESS and really get some good science. All right, well, I'm going to get into the meat of it all. So I'm going to talk about ACCESS. I'm not going to talk about a huge amount of history of ACCESS or a lot of theoretical information at all. I'm going to jump through this pretty quickly. We've got a lot of existing resources. We provided a webinar back in October. I'm sure a lot of you were there. That webinar is recorded and the slides are available. They're all going to be distributed as part of this training as well. And that provides a little bit more information on what ACCESS is. So that's why I'm just going to sort of skip over it a little bit. But I will show up this one, this little graphic. So the ACCESS is the Australian Community Climate and Earth System Simulator. It's been an ongoing effort for the last 15 years or so, not to mention a lot of the climate modelling development done at CSIRO and a lot of our other institutions before that. Essentially, an Australian climate model was determined that we wanted to build, and so we developed it based on a lot of components, both local and imported. ACCESS, both the ESM model and the CM2 model, are coupled climate models with a primary atmosphere component, which is based off the UK Met Office's model, with an ocean component and a sea ice component coupled in. Those are the DOE sea ice and the GFTL MOM components. We also have coupled directly into the atmosphere land component, which is with cable, which has been developed at CSIRO and collaborating organizations. That's a local system that we've got. And for our aerosols, we're using the UKCA model, which is natively coupled into the so it's straight out of the UK Met Office. I've also got the biogeochemistry listed here, which is an ESM-only component, which is called Wombat, which is also a local component developed in Australia that's coupled into the ocean. That's a sort of our brief one. I've got a lot of organizational logos here. All of the organizations who've contributed to this work, from GFDL and Los Alamos to CSIRO and CLEX, the Met Office. It's been, like Simon said, this community effort. It's just a huge collaboration, essentially worldwide collaboration based in Australia, and it's really exciting to be part of it. We have two ACCESS models developed mainly out of CSIRO for climate work. These two models we submitted to CMIP6. The submission to CMIP6 is still ongoing, but the bulk of it has been done over the last 2 years. These are two models that we've ran many different experiments with, and are our CMIP6 release models that we're really excited to train people up to use. We've got also a large store of CMIP6 data that we can rely on for benchmarking and comparison. So we've got both of these. I'll get into it. The ACCESS-CM2 is our more up-to-date, state-of-the-art climate model. It has one of the most recent versions of the version 10.6. It's very similar to the UK Mod Office's CMIP6 models, the HAGEM3 models, which run at a similar resolution plus some other resolutions. The ACCESS-ESM runs an older version of the version 7.3. It's very similar to the CMIP5 era models, and so we've kind of got sort of that comparison here between that said. Of course, with the ESM, we've run CMIP6 for all of it too. The atmosphere in the CM2, we run at 85 levels, which goes up well into the stratosphere, up to about 85,000 kilometers. 85,000 meters, 85 kilometers. The ACCESS-ESM is at a smaller vertical resolution at 38 levels and doesn't quite go as high. I'm not sure exactly how far it reaches into the stratosphere, but it doesn't quite reach as high, hence it running at being an older model. For the aerosols, they both run the UKCA models. However, the CM2 runs the glow map, which is the more recent aerosol model, whereas ESM runs the older classic model. Both the ACCESS models run MOM5 at 1 degree. They both run CICE, the CM2 with a slightly newer version of CICE. They both run a very similar version of cable. Of course, in the ESM, the land is interactive with a carbon cycle. The carbon cycle is run by a component called CASA-CMP, which is carbon, nitrogen, phosphorus, which is coupled directly into cable, allowing modeling of the carbon cycle, along with ocean biogeochemistry from Wombat, and it also can be used to model land use change. The CM2, in comparison, is a physical-only model. It has no carbon cycle, no land use change, and its forcings rely on concentration-driven greenhouse gases rather than the ESM, which can rely on emissions and model the full carbon cycle. Due to the nature largely of the model that's used, the equilibrium climate sensitivity of the two models is slightly different. The ACCESS-CM2 representing a noticeable increase in climate sensitivity in CMIP6 era models, which is reflected in our climate sensitivity, whereas the ESM has a smaller climate sensitivity reminiscent mostly of CMIP5 models. The two models use very different amounts of resources when you run it on the NCI. The CM2 is a lot more resource heavy, uses about 1,000 CPUs to run, takes about it runs for if you run it for a full day, you get about 5 simulation years in comparison to 16 simulation years from the ESM. The ESM runs much faster. It costs less at about 1 kiloservice unit per simulation year, as opposed to 5 from the ACCESS-CM2. The ACCESS-CM2 is a large proportion of the expensive nature of ACCESS-CM2 is the updated the extra levels, plus the aerosol the aerosol component. They also they're managed very differently, the codes and the packages. CM2 uses the Rose and Silk framework, which we run on ACCESS Dev. It has a full version control of all suites. So any new suites that are created, any new experiments that you want to run can be fully backed up into the Rosy SVN repository. In comparison, the ESM, it's run out of GitHub at the CMS GitHub. That's where it's stored. It uses the Payu framework that CLEX have developed, and they've ESM has been incorporated into. My understanding is that individual experiments won't have full version control like in the CM2, but the templates of the experiments we'll be using today are of version control. A last difference to highlight is the nature of the CMIP6 submissions that we've done with the two models. With the ACCESS-CM2, we have ensembles of typically 3. We may be extending those in the future depending on resources and availability, but currently we've got ensembles of 3 with the CM2, whereas the ACCESS-ESM typically has larger ensembles of 10, even up to 30. Our historical simulations, we're working on having 30 ensemble members. So if that's a consideration, if you want to use a model that you can compare to CMIP6 with a very large amount of ensembles, then that's something to maybe consider. Some different application differences that I wanted to highlight as well. With the CM2, a lot of the best work that can be done with the CM2 are because due to our improved the updated aerosol scheme, we really have the cutting edge chemistry in aerosols. We've got 85 levels in the providing a really good atmosphere dynamics that we can study all the way up to the stratosphere. The modes of variability are typically better modeled in the ACCESS-CM2, and especially I believe ENSO research, that kind of stuff. The ACCESS-CM2 is particularly geared for sea ice research with the newer sea ice version. We've got the higher equilibrium sensitivity, so if that's something that's you need to consider in your work at all. And also the ACCESS-CM2 is directly comparable to the UK Met Office's Sigma 6 era models, of which there are several. As opposed to, on the other hand, the ACCESS-CM2, if you want longer runs, larger ensembles, or you just need it to be cheaper to run, the ESM is definitely something to consider. If you're looking at studying the carbon cycle, land use change, emission-driven CO2 experiments, or ocean biogeochemistry, ESM is where it's at. That's what you'll want. With the lower ECS, of course, and it's also being used for paleoclimatology work out of University of Melbourne in New South Wales, I believe, as well as the potential for geoengineering type simulations as well. So just to highlight some differences between applications, help you make your choice in about 5 or 10 minutes time. We've conducted a lot of experiments with our models of ACCESS, as I mentioned before. I won't go through these in detail, just wanted to highlight that we've got many experiments done. We've got the full deck, what they call, which is the standard base level simulations of CMIP, PI control, historical experiments with a range of ensembles. We've run the scenario out to 2100. We're running some extensions currently. As I said, the CM2, we've got ensemble members of 3 and 10 or more from the ESM. Also run a range of different experiments from other MIPs within CMIP6, some ocean-focused FAF-MIP, some carbon-focused C4 and CDR MIP, paleo research DA MIP, which is ongoing for the CM2 and published for the ESM. We've participated recently in a COVID MIP, some specific COVID style scenarios. And so they are ongoing, beginning to be published as well. We're working on some OMIPs, some OMIP experiments with COSIMA's OM2 and 1 degree and quarter degree models. And we're running some extensions of the scenarios out to 2300. So we've got lots going on, but lots already there. You can access this data from FS38 on Gadi. That's our models. Other models you can also access on Gadi through the replication node on OI10. You can also access all of the data through the ESGF portal. As you can see here, our 2 models are highlighted with a very large number of data sets already published. And we can provide any assistance to anyone. I won't go into CM6 data anymore because there was a 4-hour training on that kind of stuff related this morning. Also wanted to mention we've got a website for these two ACCESS models, where we're doing a lot of tracking of CMIP 6 releases. We've got a lot of links in there to errata, model description papers. These links will be included at the end. And I've got some useful links here. These slides will be made available, so you can always pour through them at any time. I'm going to get on to almost ready to start splitting up into our groups and start getting into some training. I want to highlight, I've put together a Confluence page. We have an ACCESS Confluence page that's hosted at CSIRO that I have essentially built all of the training for today in. The ACCESS-CM2 training, I have a lot more physical documentation in than the CM2, but there's a lot of material here that's applicable to both. I have here the Getting Started with ACCESS webinar. I'll send this out. I'm happy to send a link. I'll put that in the chat once I've finished this presentation. Once you go to this link, if you haven't watched the webinar, if you didn't attend the webinar or you haven't watched it at all from October, you can see here I've got a link to the video and the slides. Also, as part of today, we've got the CLEX ACCESS Slack channel going. You can use that for communication throughout this training if you want. Scott Wales is going to be manning that for us and keeping an eye. We've got two channels, one for ACCESS-CM2 and one for ACCESS-ESM. You can join that easily if you've got a CLEX University email, a CSIRO, or a BUM email as well. You can get directly into that. That's all. We're pretty much ready to start moving around. So if you are wanting to stay here for the ACCESS-CM2 training with me, stay where you are, don't touch anything. If you're interested in learning about the ESM and joining Holger, you can join the breakout room. You should be able to do that. Looks like the breakout room is now active. I just got a little pop-up saying with all the details. Should be able to join that on your own. It's totally up to you which one you join. We've got an hour. At 3:30 we'll have a break, and then at 4 o'clock we'll resume back here in the main meeting, not in the breakout room, and then we can go. I'm just going to, before we get going, now I'm going to get sort of into what I'm going to actually present today. I've put together an ACCESS-CM2 training sort of tutorial here, essentially. Comes in 3 parts. The first part here is purely just for setting up. I'm not going to go through this today, but it shows you how to, leads you through stepping through getting an NCI account, joining the getting a Meta Office account, getting onto ACCESS Dev and getting ACCESS Dev set up, which can be quite a process sometimes. And then I've got some links in here to the Getting Started webinar. If you do want to come back and do this training at all and you haven't watched the webinar, I highly recommend that first. We've also got some extra CM2 user guide that you can peruse later on. I'm going to skip over this one and jump straight to our the second part of the tutorial. This is where I'm getting into it. This is what I'm going to demonstrate today. Before I get started, I wanted to just give a small breakdown of what I've prepared and what I guess who my target audience for this was. I started only at CSIRO 2 years ago. I joined straight out of a PhD in astrophysics. I joined the climate modeling team, and I had a lot to learn. Fortunately, I was in an office with and in a team and supported by some very well, some experts in CM2, some very well-trained people, some great people who provided me a lot of support and training. Peter Doppelhoff, Martin, Dix, Arnold, Sullivan. However, I wanted to write something and prepare something that perhaps I would have wanted 2 years ago. Something that if I had sat down straight out of my PhD and went, okay, I want to use ACCESS. How do I use ACCESS? Wow, this is very complicated. Rose and Silk system can be quite intimidating at first glance. And I wanted to develop some kind of a resource that would not only teach you how to use a lot of the basics, but also something that you could easily go back to, that you could run through. It would take you through step by step. And by doing this tutorial, you'll get a good understanding of how to use it, not necessarily the logic or documentation kind of style explanation of ROSE and Cycl and what CM2 is and how ACCESS Dev works, but a functional demonstration of how to use it. So what I put together is essentially a step-by-step tutorial. It's quite lengthy with 2 parts that will essentially run through making a copy of a suite, making a whole bunch of alterations to the suite, running it, doing a small amount of debugging and resolving some issues, getting it going again, and ultimately having a look at the model output in the end. So what I'm essentially going to do today, because we weren't able to perform this training in person, if I was sitting in a room with you, I would have you all hopefully with a laptop running through this step by step. However, that's not the case. We've only got a very short amount of time. So I wanted to provide something that you could come back to. As I said, we're recording this video. This tutorial will be available. I'll have all of it collated in one place so that if you do decide that you want to use the ACCESS-CM2 and you don't really know how to use it and you want to spend a little bit of time getting to know it before you try and do your own research with it, you can come to this anytime, run through the tutorial in your own time, at your own pace, whenever you like. Refer to this video if you get lost at all, and ultimately you can email the CWS CLEX help desk, which I'll provide at the end, and we can kind of help with that as you go in your own time. I'll get into it. ROSE and Cycl is a package developed largely out of the UK Met Office, also in collaboration with NIWA. I think NIWA, who with the original out of New Zealand, were the original people who developed Cycl itself. ROSE is essentially a suite manager. It's a GUI interface. It's a wrapper for SVN. It manages the suites, altering the suites and running the suites. And Cycl is the cycling job scheduler. It's what actually runs when you run the CM2. Cycl is what reads all the scripts, conducts all the tasks, organizes everything that ultimately makes up the CM2. I won't go into huge more detail, but you'll see them being demonstrated anyway. Everyone can see my screen just fine. The using CM2 suites in Cycl and ROSE and Cycl. Give me someone say something because I can't see the video. Thank you, Simon. Thank you, Simon. Just wanted to double check.
Sorry, Chloe, do you think maybe you can zoom in a bit? Because, yeah, because I think once recorded, it will be easy to watch it after that.
Yeah.
Thanks.
So we have ultimately what we've prepared is 3 suites, 3 ACCESS-CM2 suites that are CMIP 6 essentially standard suites that are designed for you to load up and run essentially the exact same experiment that we ran for our pre-industrial control, historical, and AMIP, which is the atmosphere only scenarios. These are BR656, BX616, and BN157. They are available to you at any time to copy and then make adjustments to. That's essentially what I'm going to do today. I'm going to make a copy of the historical experiment. I'm going to go through the suite, make a few tweaks, make a few changes that I think some people, the kind of changes that some people would want to make. Nothing too in-depth. I'm not going to be going into the code. We're not going to have Fortran. We're not going to be recompiling any models or anything like that. Just suite level alterations to the experiments. I won't be using the release suite itself today. I'm just going to turn off my aircon. It's a little cold. I'm going to use BX616 today. I've prepared a separate suite just for this training specifically. It's this one here that I've prepared. And I'm going to get straight into it. If you want, you can follow along this tutorial and you can see all the steps. This is everything I've written up. I'm essentially going to follow this step by step in this tutorial so that you've got this as a reference. You can watch me while you follow through on the the Confluence page. If you're really adventurous and you already have an ACCESS Dev login, feel free to log in and try to keep up with me, but I'll be going through this relatively fast. So don't feel like you need to follow every single step that I'm doing. Feel free to just sort of observe and follow along with the documents. All right, I've got myself a terminal here. I'm using a virtual machine. There's also VDI virtual options called Strudel, I believe, out of NCI. There's various different ways to get onto NCI and ACCESS Dev. However, I'm using just a virtual machine that's running Ubuntu in it because that's what I prefer. I'm going to log on to ACCESS Dev. I've got an alias here that I've created, and so we'll log in with SSH into ACCESS Dev. You'll need this -y or -x flag to make sure that you can open the Rose GUI X forwarding. Once I log into ACCESS Dev itself, I'm simply in my home directory. The first thing we need to do before we use anything here, before we can use Rose and Silk, is we need to authorize ourselves with the Met Office. So we've got this command called, in my head I call it Moses auth because that's how it looks. This will authenticate yourself with the Met Office SVN repository and allow you to interact with Rosie. Otherwise, you will have trouble making your own suites and checking out your own suites. I've already given my password today to this, but it will ask you for a password. We're going to go into the Roses directory, which is should be automatically there in your home directory. This is where this Roses directory is where all of the suites are kept, and where all of these suite changes are going to be made. This is our main directory here. Beginning with, I'm going to do what we call a Rosie checkout. I'm going to use Rosie to check out my suite that I've prepared. My suite that I prepared is U-CB905. I'm going to check it out. What that does is it just makes a local copy of the suite. I can't update the suite. I can make local changes to the suite, but I can't upload it back into the ESM back into the SVN if I wasn't the owner. Of course, I'm the owner, so I could. This is useful for inspecting suites, existing suites. You could do a local checkout of any of the CM2 suites that I mentioned earlier, have a look through them. You can even run them as is and make changes. And I'll show you what it looks like if you do that. So you've got, all it does is check out some directories, and we've got some directory structure here with a few very important files that we're going to look at. Under app, essentially what we have is all of the different tasks that ACCESS-CM2 runs at various times, running the CIS model, running the coupled model, creating drivers, that kind of thing. All of these configurations are stored under here. Under meta, you can mostly ignore that. It contains metadata information for the Rose GUI that we'll see very soon. This is a control that is specific for a specific task related to Ozone. I'm not going to talk more about that now, but we have three very important files here. We've got rosesuite.conf, which is our main configuration file, rosesuite.info, which is our top-level information file, and we've got suite.ic, which is ultimately our Silk control script, which is what Silk uses to make all of its decisions. I'm not going to use this local checkout. What I'm going to do is go back, and I'm going to do a Rosie copy. What a Rosie copy is going to do is create a brand new suite in my name, in your name, if you were doing this, and it's going to create a new unique identifier, a brand new suite for you to use and update back to the SVN. You can make copies directly out of that as you wish. This is the first step in using ACCESS-CM2, making a copy of an existing suite. It's really where you want to start. You can fill out some basic information here. This is the sort of top level information. I'm going to leave this as is. for now, but you can change that in here. It automatically uses the Vim interface, which I don't really prefer myself, but we're going to accept that. I'm going to press Y because I do want to make a copy of CB905. It'll take a second just to do that. What it'll do is it'll give me a brand new suite name, all for myself, to do whatever I want in, and I can make all the changes from there. It's taken its good long time. Come on. Come on. Okay, so that's not responding. Let's imagine it did. Fortunately, I have this. You'll see some info. It'll create a new suite for you. It'll copy all the items in there, and it'll create a new suite, and it'll create a new directory, which you can then easily navigate into and just start using. Oh, just did it in the background. Give that a second. I did have a backup. Ah, look, here we go. CB995, it's created me. It's just created that for me now. So I'm going to go into that directory. Looks exactly the same as what I showed you from CB905 because it's a direct copy of it, but we're going to go from here. Now I'm up to part 2 of my training, of the tutorial here. We're going to have a look at the rows GUI, and we're going to look at some suite configurations that we can do, some top level ones, nothing in depth just yet. To open rows, we use rows edit. I'll chuck an ampersand at the end just so I can keep using my terminal here, because there are multiple ways of inspecting this information, and I'll show you both ways to make changes to the CM2 suites. This is the rows GUI interface. Here we've got a list of items we can select. We've got the suite info. This is the suite info that they asked us when I first did the rosy copy. We can directly see that by inspecting the rowsuite.info file, which contains the exact same information, purely just whether you want it in text form or GUI form. You can adjust this at any time. You can put extra notes in here for yourself. And that's pretty much that. We won't talk about that anymore. Next level down, we've got suite configuration. Suite configuration, which we can expand using that. This is the main top level configuration. This is the broadest strokes of how to control the ACCESS-CM2. We've got various pages here under the suite configuration that we're going to look at. I'm going to go through a few of these. Additionally, this file here, the rowsuiteconfiguration.conf, we have a look at that. What it really is just straight up and just a name list with variables that you can define. The rows interface just reads this file and portrays it in a way that, with some extra metadata, makes it a little bit easier to use. I like using the rows interface for most suite configurations, but people like it different ways. So there's 2 different ways to do it. First of all, we're going to come to this build and run. This is the absolute top level. So this is where you can turn on and off full components, including MOM and CICE. You can prevent it from installing a lot of different various parts of the model. You can turn on and off the NetCDF post-processing, which happens after the model's run, which I'll talk about later. You can even prevent it from running the model itself. I won't change any of this now, but this is an important screen to consider. Under machine and runtime options, we control how, essentially, when ACCESS-CM2, when the suite sends tasks to Gadi in order to run, because most of CM2 is actually run on Gadi, not on ACCESS-Dev. ACCESS-Dev collates the tasks and the scripts and all of the suite information, sends it over to Gadi, which runs it mostly on the PBS on the queue. We can control what we run on, what core types, what queues we use. What I'm going to do is I'm going to change from Cascade Lake to Broadwell. CM2 can run on either of these. Cascade Lake is the newer, the Gadi standard nodes. They're slightly more expensive to run than Broadwell. Broadwell are the old nodes left over from Rygen that have been migrated over to Gadi and now can be used. They have a lower cost of SU cost, and so we typically like running on Broadwell. Saves a little bit of SU, but you can run on either. We've got the normal queue and the express queue that you can also run on. I'm going to change this over to the express queue for this. Just note that express queue will cost you, pretty sure at least double the amount of SUs. So I wouldn't suggest using the express queue for anything other than for testing purposes. What I'm presenting is a test, so we're gonna save that. I'm gonna run this in the express queue. Additionally, I wanted to highlight here the compute project. The P66 is our main ACCESS project that we run most of ACCESS-CM2 out of CSIRO. Obviously, if you're part of CLEX or any other institution, you might have a different project that you want to use. This is where you'll change that. V45, whatever your project is, that's where you'll change that. Great, now that we've adjusted some of those, I'm going to come down to run initialization and cycling. Here, we control a lot of how the model, where the model starts from, how it's going to run. We run it from 1850. We're running it, it's currently set to run for 165 years because it's a historical experiment with a resubmission. Cycl runs in cycles, and it has cycles, and you can set the length of time for a specific cycle where it will perform post-processing after the cycle. I'm going to change the run for this to 2 months. We're going to run it for 2 months, and I also want it to resubmit every month. This is just for testing purposes. This means that I can check that all of the full cycles, a couple of full cycles work without having to run years of this at a time. We're going to run this as a warm restart, meaning this suite is essentially going to spin off an existing run. That run is BI889, which was our release of the PI control. So that's our CMIP6 PI control scenario. It began at year 950 internally, but you can spin off if you've got the restarts of any year, you can spin off from any year in any experiment. You just need all of the restart files for whatever simulation we want to spin off. We're going to change that warm restart value just to 1050. So we're going to pop that up 100 years and branch off from a different point in our PI control. These historical simulations, we've got 3 ensemble members. The first one branches from year 950, the second branches from year 1000, and the third one branches from year 1050. So I'm going to branch off similar to our third ensemble member, and I'm going to change this to year 1050. I can show this later if I've got time, but you can inspect this anyway if you have access to the ACCESS project. I've included the restarts for this year in that project so that I can spin off. And so we're essentially going to run a small 2-month test branching off year 1050 from our PI control. I'm going to save that. Of course, you can spin off any CM2 CM2, you just need to alter the restart directory to any other restart. If you've got your own restarts, if you've got a simulation that you've previously run and you want to spin up a new one branched off it, then that's easy to organize these variables here. That's all the changes I'm going to make at the sort of macro suite level. What I'm going to look at now, we're going to go a bit more in depth. We're going to have a look at some configuration. In the tutorial, I'm now up to part 3 of my tutorial, component configurations and science settings. We're going to start with the which is a very, very important component of the ACCESS-CM2, which I'm sure you can understand and you're aware of. To do that, what we're going to do, I'm going to show you how to make changes in both the Rose GUI and in the terminal. In the Rose GUI, click on the UM down here. This is just this UM list here controls everything that the atmosphere component will do. You can alter all of the variables and many different name list items throughout throughout this underneath the UM here. Similarly, everything can be done through under app in the text files in the rows directory. Under here in UM, oops, we've got rows app conf. That's our main configuration file for the UM. So I'm going to have a look at that. We've got app, UM app, and the configuration file for the UM app. Again, this is a very long name list file that contains everything that is able to be altered in here. They're the same information, just offers two different ways to make the changes. Of course, the UM name list file is 6,000 lines long, and so I find, in general, the rows GUI a bit easier to use. I've got some basic settings, some environment-based settings that I'm going to have a look at here. We've got a print status here. We've got various settings. I encourage you, if you're doing this tutorial, to spend some time, have a look through the different settings, just get a feel of all the different things that can be adjusted. I'm going to obviously go through this pretty quickly. I'm going to click on, switch over to some extra diagnostic messages here. You can control the amount of message that you get from the UM. Since I'm going to run a test, I'm going to bump that up just for today, and I'll click save on that. Get a bit more in depth into it now, but first of all, what I want to do is I want to highlight, I've got some top level model control here, some under the name list. This name list item under UM is where most of the variables and most of the controls are. Essentially, what Cycl users and rows use are these long name list files that control all the different variables. Under top level model control and model domain and time step, we can change the actual model type. We're going to leave this on global model, and I assume most of you would, but there's also options for running the ACCESS-CM2 in a single column model, which I believe can be useful for particular size cases, although I'm not going to discuss that any further. I also wouldn't suggest you just load up one of these suites and switch to that. I have no idea if that would work or not. But if you are interested in using a single column model version of the CM2, please contact us, and we can send out some suites and help you get started if that's what you're after. But we're going to use a global model for now. I'm going to move down, and we're going to make some slightly more in-depth changes into here. And I want to highlight under reconfiguration and ancillary control is an important part of what we're going to do here. A lot of different science technical options here, of course, that you can read through and have a look at. Under configuration, configure ancils and initialize dump fields is where a lot of the input ancillary files that CM uses can be adjusted. In particular, forcing files. We've got most of these are switched off, indicated by the little exclamation mark. But we've got ozone forcing that is given by a file that's stored on Gadi. We've also got leaf area indexes and PFTs that are fed into cable. We've got some DMS concentrations, some ocean-based, some ancillary files. For the purpose of this tutorial, we're going to change our ozone ancillary file. Of course, this is a historical scenario, which means that the ozone ancillary that's used is a time series. It's a time series between 1850 and 2014 that was prepared as part of CMIP 6. I'm going to change this. I've included in the tutorial the file, the name directory that I'll be using. So I'm going to use a time slice. I'm going to fix the ozone to 1850. I'm going to use just a time slice, so it'll repeat over the same year of ozone, and I'm essentially going to take out the ozone forcing from this. It's one of my main changes I'm going to make in my little experiments. I'm going to change that, and I'm going to save that. I won't change anything else in here because all of this, the settings are all still the same, so that won't be an issue. This is how you change many of the ancillary files, and some important location in rows to be aware of. Additionally, for other forcings, including greenhouse gases. Oops, that's not the right one. Let me just consult my notes. Under the science settings, I'm going to jot this down. There's many different settings here, controlling a lot of different aspects and different algorithms within the model. Under section 0102 radiation, we have gas MMRs. This is a very important component. So we've got CM2, CO2, we've got nitrous oxide, we've got CH4 and O2, and a range of smaller, so we've got some HCFCs defined here. In this more top level directory called gas MMRs is where we defined fixed values for the greenhouse gas MMR values here. These are used in experiments like the PI control that aren't variable. However, if we want to use time varying greenhouse gases, like in a historical experiment, we're going to want to switch that on here and underneath in varying gas MMRs, open that up, and we can go in and we can adjust each of the different species separately. I'm not going to make any changes, but I do want to demonstrate what is involved with this. Each one of these little boxes is a year containing a CO2 concentration that will be used within the model, beginning in 1850. Each one of these boxes, these are the years that correlate to each of the values, and they run for 167 years. Can be a little bit tedious if you need to change a lot of these. So if you find yourself needing to change all of the CO2 values, I would suggest using the text file, the configuration file. And if you come under here, it's literally just a text file that you can you could prepare these columns and these tables separately and just copy and paste them in. That's what I usually do when I'm changing these. I find that to be a slightly easier way, but you do need to define them for each particular year and make sure that the years that are given for them correlate to what they are. So I would be careful using this, but I just wanted to give you a little bit of a rundown in case that's something that you'll be using. That's all I'm going to talk about as far as forcings and ancillary files into the My next aspect, I'm up to step 3 in section 3 of the tutorial using CM2 suites in Rose and Silk, if you're following along at all. The next part I want to talk about is the stash. I know I'm going through this extremely quickly, but feel free to consult this later on. Model input and output. Model output streams. Oops, not that one. Stash requests and profiles. That's what we want. Stash requests. Stash requests are essentially telling the suite, this is what I want in my model output. When you go into your model output after the model is run and you have your netcdf files, these stash requests is what you're going to see ultimately, and it tells the model which fields you want, in what frequencies, what kind of coordinates. The stash items, each stash item is a particular item that is defined in the itself. I've got some links in the tutorial so you can explore some more stash items if that's something that you want to do. What I'm going to do is I'm going to group these by section. These stash sections, there are many different stash sections. You can see up to 50 here. There's a lot of numbers missing, not really sure why, but they're split up into many different parts of the model as well. Radiation, dynamics, aerosols, lots of different parts. Each item will appear as an output field in the model output, and you can turn, and everything that's listed here in this page, in all of these, are loaded into the suite and can be simply turned off and turned on by clicking the include button and saving. And all it does is turn that on so that you'll see that in the model output. The little exclamation mark also indicates that it's deactivated. Stash items can be grouped into packages, so that if you've got a particular package of stash items that you say want turned on and off in different circumstances, you can group those and name them quite easily. We've got a particular group of packages called Here's to Extra we're going to use. Here's to Extra is a bunch of extra fields, daily fields, but mostly sub-daily fields, 6-hourly and 3-hourly fields that were required for our CMIP 6 submission. You can use these if you're interested in doing downscaling or you need some sub-daily data. I suggest having a look through the Here's to Extra package for fields that you might need. I'm going to turn that on for this experiment, and I'm going to save that. So I've now loaded in somewhere in the range of about 50 extra stash items automatically, just as easy as that. So that's really helpful there to put them all on. You can see the ones that are Here's to Extra here. They're labeled. And so that's really easy. You can turn that on and off. There's a few other ones. We've got some diagnostics. We've got some cable fields that you can turn on and off at your leisure. And you can experiment with those. However, if there's any items or any fields that you particularly wanted that aren't currently loaded into the suite, you can do that. You can load almost any stash item into the suite. If you click New up here, you'll see many different options. There's a lot of different stash items you can add in. Difficulty is that you have to kind of know what you're doing a little bit here, and it requires a bit of experimentation. However, I'm going to demonstrate adding a field. Before I do, I want to highlight what I'm going to do is I'm going to add surface temperature after time step. I've already got this loaded in. I've got this saved monthly and I've got it saved daily. But let's say I wanted to save this field not only monthly and daily, I also wanted to save it every 6 hours. And so I simply go in and I add another one of these. This is stash item. It's in section 0, which is the primary fields, and it's item number 24, surface temperature after time step. Add that in, double click it, pop it in. I can see it here now in my window with a lot of angry X's. Angry X's mean that I haven't told it the suite what I actually want to do with it. I'm going to fill out these 3 columns. I'm going to tell it to diag. A lot of these, I don't expect everyone to be able to figure out exactly what these are. These are 8 pressure levels, 19 pressure levels, soil depth levels. We're going to choose diag, which is just a two-dimensional field because it's just a surface temperature. I'm going to ask it to use a frequency of 6 hours. I'm going to ask it to put my 6-hourly data in my 6-hourly output fields, which are UP7. This UP7 will be a little more obvious what that means at the very end of this training when I talk about the model output. But for now, just know that that's what I've done here. I've added in 6-hourly surface temperature here as an additional part of my model. I'm going to save that. An extra thing I want to mention just before I move on from the stash is a range of macros that are available. I'm not going to run all of them. However, the tutorial does suggest you run all of them, and they should run. Essentially, there are 2 categories, some validation macros that we'll just go through and check some metadata, check that nothing seems to be incorrect with the stash that you've loaded in. It can cause pretty drastic errors if you are loading items into the stash incorrectly, and these macros can help prevent that issue. I'm going to run tidy stash validate here, and let's see what it gives me. It's come up with 2 errors. This first one This first one relates to the item that I just added into the stash. Because I added in a brand new variable into the stash, it's given it an index of 1, and this macro has complained, and it doesn't think that 1 is a very good index. It wants something a bit more rows language, and so that's what it's telling me here. There's a second area here. We've got a duplicate of some time variables. I'm not going to worry about that. I'm going to leave that one as is, but we can fix this top one with another one of these macros. I'm going to run the tidy stash transform. We just ran the tidy stash validate. I'm going to run tidy stash transform. And what that's going to do is update my field that I just introduced into the stash, and it's going to neaten up a few things for me in a way that we don't really have control over. The macro does. I'm going to apply that, and it's settled out. So this is my new field here. It's got an appropriate index, and that's all good. We've still got that one last error here, the time profiles. I know for a fact that I can ignore that, and there are a lot of errors that come up from these macros that you can potentially ignore, but they can be very important for highlighting and discovering issues before you run the model and get deep errors. So I suggest making use of these macros and maybe trying to identify a few issues. It's giving me some angry exclamation marks, and I'm just going to refresh my metadata in the rows GUI just so that it stops complaining about my errors. That's the stash. I've introduced a whole bunch of extra subdaily variables from the Here's the Extra package, and I have also added my own surface temperature 6 hourly field there because that's what we want for this experiment. That's the stash for now. We're going to leave that. In fact, we're going to leave all of the I'm going to close up the there. I won't be making any other changes to the suite, but I did want to show you the mum and the CIS name lists just quickly, just so you can see where they are. To get to the mum name list in the terminal, you'll want under apps. We've got mum here, so open mum, and then we've got the rows app.config. It's the same name, very similar to the one, except that here we've got all the ocean variables and name list files that we can adjust here. Similarly, we can open that in the rows GUI, see all the name lists, and make many different changes. I'm not an expert on the ocean, so I don't really know what most of these do, but if you are wanting to do some ocean-focused research with the CM2, I definitely suggest having a look through here and getting familiar with some of the type of changes that you can make. Similarly with CIS, the configuration file and the app CIS, and the old rows app configuration file. Again, very, very similar, a name list file that is represented visibly in the rows GUI with different controls for CIS, including here the ice fields name list, where you can turn on and off output fields, very similar to the stash, but a little bit more simple. M indicating monthly, D meaning indicating daily, and X being turned off. The CIS output fields, output files are not very large, so don't feel like you need to turn off a whole bunch of CIS variables to save yourself space. You're not going to save yourself much. The is really where a lot of the data is. If you're looking at saving space in your model output and you don't need subdaily data, I would suggest turning off anything that's subdaily. Or if you run it, you can go and delete any subdaily data that you don't need afterwards, after the fact. That's what we've got for CIS, and that's what we've got for our suite. What I'm going to do now is I'm going to run our suite. I've set up our suite. I've made a few changes, changed the stash a little bit, changed some input, the ozone ancillary. I've made it only running for a couple of months on the Express queue, but now we want to run it. How do we run it? And I'm up to part 4 of my tutorial here. Now we use the rows suite run. One little command is going to run the whole thing. So we're going to get that going. Give that a second to load. Ooh, running out of time. I'll push this through this as quickly as I can. I'm sorry. We'll get through this. While that's loading, what I might just do is sort of jump into our next step. And I have one that I prepared earlier. I have a copy that I did, and I made all these changes to. And I have it running here. I'm going to show you. What it looks like, because I don't have the time to sit and wait for everything to load. This is what the Cycl interface will look like. It will run through all of these succeeded items were performed before the model runs. It'll download the configure the model, and it'll compile it on Gadi. It'll download a whole range of drivers and compile those. It'll download CIS and compile it, and it'll download MOM and it'll compile it. It'll install our ancillary files, that, of which there are a vast number deep within the CM2 suite at different points. It'll prepare our warm restart based off our PI control. And finally, after it's performed all of that, it will try and run the coupled model. Unfortunately, in my test here, I've done something wrong and my coupled model has failed. What you're going to want to do is figure out why it failed. So I'm going to show you the Cycl run directory, which is the all of the logs, essentially the log output of ACCESS-CM2. Once it runs, you'll be able to log onto either onto Gadi, and you'll be able to come to a directory under your home directory called Cycl run. Cycl run directory also exists on ACCESS-Dev, which is still busy building my suite that I was running earlier. Cycl run directory here, which I've logged set into my my pre-prepared suite here, which is a similar copy of 905 from before. It copies everything from the rows directory. So the app and the meta, it's got the ozone control, the suite control here. That's all copied straight from the rows app, and you can see that all here as well. What I want to focus on right now is the logs here. This log link here is a symbolic link to the most recent logs. And so I'm going to browse into that here. Under logs, we've got two options, job and suite. Suite level errors, I never really had to worry about. Most of what you're going to want to look like is jobs. And by jobs, they mean the apps, the tasks that have run. All of these are jobs. You can see the log output of any of these jobs that have run. So I'm going to browse into there. We then have a look at our cycle. So because we've only just started our model and it's trying to run it for 1 month in 1850, our first cycle is 1850-0101. So it's the coupled job in cycle 1850-001 that we want to look at. So that's what we're going to browse to. These are the tasks that have so far run. As you can see here, you can compare, make make drivers, install AMSIL. We can look into any of those. Obviously, it was our coupled model that failed, so we're going to have a look into that. If you do want to know more about all the various tasks that are run, I do give a short breakdown in the tutorial, so feel free to have a read. Obviously, I'm going through this very fast for this demonstration. The tutorial contains more information, more descriptions about various things. We're going to have a look into coupled. These, now what we have are the attempts. These are job attempts, essentially. Every time a task fails and then you need to resubmit it, it will increment the number of attempts, and the link NN will always link to the most recent one. So we want to just look into NN because it'll be the most recent one that failed. But it stores everything from any previous runs. Our job log directory has 4 files in it. I'm going to quickly have a look at those. The job file, this is simply the Cycl script that we've got. This is what Cycl is provided with and what it runs through at various points, including a lot of name list files. We can ignore that one. Similarly, we've got job.status. This provides information about the PBS job, including the PBS, the queue name, the job name that was submitted to the queue, when it was submitted, and some basic information that it finished and it exited. That's, you know, you can get some important information here, but for our purposes, we're not going to need that. Then got 2 left. We've got job.error. Job.error is the standard, the std error output. It's a standard error stream from the PBS job. It's fed into this file. So this contains the error information from anything that's fed into standard error, and it's a very long file containing a very large amount of information. For looking for errors, of course, we want to go straight to the bottom, and it tells us here it failed, had a return code of 9, and we had a critical issue and caused it to fail. It's not particularly useful, but at least we know that Cycl is not lying to us, and that's what failed. Last of all, we're going to look into job.out. This is the standard output. This is the main information that's printed in the PBS job, and it's sent to this file. Similarly, let's skip right to the bottom because that's probably where our errors are. Sure enough, warning, error. It's pretty obvious that something went wrong here. What happens? Struggled with our ozone ancillary file. Couldn't find our ozone ancillary file, and due to that, it failed. It's pretty good to know. We want to have a look. We want to find out what happened to this file. It was unable to read the file, so let's have a look. Try and figure out why that failed. What I'm going to do is this is on Gadi. This file is stored on Gadi. What I'm going to do is I'm going to navigate to the directory that's stored in. Check if that even exists, the base directory, let alone the file itself. I'm going to have a look in here what's in this. Here's the file. The file's there, and it failed to read it. And unfortunately, because I'm a coder and I tend to make these kind of issues, I've got a small typo. I've put an underscore. I've got edited underscore ancil, whereas the actual file has edited dash ancil. So that all it did was the path name was wrong. That's an easy fix. I'm going to show you how to fix that up. The suite obviously failed, so we need to go back into the suite and I need to correct that error before the model can keep running. Fortunately, I know what the problem is now. I'm going to make a copy of that file name so I can copy it in correctly. And I'm going to come back. Now, my original suite copy created it and opened it up, and that's fine. I'm going to leave that. I'm going to come back to my pre one here. Back into my suite, just as before. I'm going to load up rows edit. Oops, rows edit. Let that load. I'm going to make some adjustments. In the meantime, I'm going to just close this Cycl GUI just to get it out of the way. For those following along, I have actually gone on to our next tutorial. I should have mentioned that. Gone on to our next page, and I'm on part 5. Cycl error messages and basic suite debugging. This is what I've worked through so far, and I'm somewhere around here, step 2 or 3. I'm going to navigate back into where we declared the ozone ancillary file under the UM, under the name list, under the reconfiguration ancillary information. Coming down here, this is the ozone one here. Not a very good name. 24D9C434 is a bit difficult to remember, but it's what I've got to work with. I'm going to open that up. This file name is obviously wrong. I'm going to just paste in our new one with the correct file name here and give that a save. That's it. That's all we need to do to fix up this. However, we do need to run our model again. There's a few ways we can go about controlling the models. Our model is actually, the suite is still active. Even though I closed the Cycl GUI, the actual suite itself is still active. Cycl is still running in the background. We can find out whether this is running. We've got a command called Cycl scan. If I type in Cycl scan, it'll tell me what jobs I have running. I've got this one that I worked on earlier that I created, 995. And then I've got this one that I was just doing. This 995 in the background, probably in about half an hour's time, it'll hit the exact same error that I just resolved. Currently, we're working in this one here. So it's still active, meaning it's still waiting for me. I can reload this at any time with rows suite G control. So we're almost about to hit 330, but I'm almost done. Almost done. Rows suite G control. I'm going to load that up. And that all it will do is just open up the Cycl GUI and bring me back to where I was. Problem is, I haven't told Cycl that I've updated the suite and then I need it to do an update. To do this, we can reinstall the suite, what we call a reload. So I'm going to do rows suite run -- reload. See how long. Access Dev is a little slow today. Oh, that's not too bad. What it'll do, it'll load the suite back up into the current instance of Cycl, including my fix of the ozone ancillary file name. Once that finishes, we're ready to go, and I can do it again. Oops. Looks like the ESM are starting to come back. Almost done here. And that's going to reload it back into the suite, at which point we can just initiate it and get it to go again. I've got some other stuff here. I might skip over this. However, the tutorial will talk you through shutting down a row suite in various different ways, including some kill switches in there. And we can restart the suite. If a suite has been shut down, you can either restart it to be exactly like I've shown you now, and that's with the rows suite run restart, the restart flag, and it'll essentially put Cycl back into the exact same state as when it was shut down. There's also another command called rows suite -- new. I find that a very helpful command if you're having problems at an early stage of getting your model running, if you haven't even got it fully running yet. What the new flag does is completely wipes the Cycl run directory clean, and it does everything from the get-go. It'll recompile the model, it'll re-download everything from the repositories, a completely fresh start. Sometimes it's easier to just start from the beginning, even if it takes you an extra half an hour of waiting. That's some extra stuff that we've done. For the moment, we're going to hit run on our model. Because it's failed, it's sitting at it failed and it's not moving to start with, but I have fixed it. And I've reloaded it. So I want to just manually trigger it to go. And I can just left click on the couple job, click trigger. And it will run it again. It'll send that to the queue and it will run the job. That'll take, this whole 2 months will probably take about an hour or so to run. I'm not going to sit here and wait for it to run. I do have a pre-prepared, a second pre-prepared suite here for when we come back in half an hour, and I'm going to talk about the model output, because now that I've corrected my error, I do know that it's going to run smoothly and finish up. Thank you everyone for listening to me go through this so quickly over the last hour.
/COE-CMS/ESM pre-industrial, that's obviously the pre-industrial experiment for ESM. Then you will get this page, and included in this page is a documentation about how to run ESM, including a quick start guide. And because it takes a little bit, I decided to just run you through the process of downloading and running the model. And then while it's running, I'll explain a little bit more about the configuration. So we first need to be on Gadi, obviously. So I'm here on Gadi, and then I make an ACCESS-ESM subdirectory in my home directory. This won't be very, this will not get very large. Everything everything that contains a lot of data will be linked. So it's not that bad. It won't take a lot of space in your home directory. And then once you do that, you use the command git clone, and then this address, and this will install everything in. That will download all the configuration files and everything into your directory. So it now has this ESM pre-industrial. Now, just of course already have forgotten the first step. Oh, you need to be a member of HH5. You can, if you just request membership of the NCI group HH5, you will be given access, but we will use the Payu is part of this, is located there, and without that you won't be able to run Payu easily. So module use G data HH5 public modules, and then module load conda. Now, in this, it says still the unstable version, but since that Payu has made it into the stable version, so you can just use module load conda. So we've checked it out. We're in the directory. Now it says because, as I said, it keeps track of all the changes. So that will mean that there will be a lot of check-ins coming in. So a lot of commits coming. So I recommend that you then create and check out a new branch just for the runs. So if you look at the status, it's there, and then let's have a look at the thing itself. So we have the main configuration file here. This main configuration file tells us everything about how the model is configured, and then it has these subdirectories for the different submodels. So atmosphere for the ice for sea ice, ocean for MOM, and coupler for the num couple file. But to just run the model, all we have to do is Payu run. This will set up a new run from the start, and you can see that it's running, or that it's queued, and it will eventually execute. Payu run will just submit a single run, and a single run in the ACCESS-ESM model means 1 year. Once it's run, you can just use Payu run again to calculate the next year, and so on and so on. But because that's a little bit tedious, what you can also say is Payu run minus n, and then whatever how many years you want. So minus n25 would then run the model again and again and again until it has reached 25 years. So while it's running, let's have a little bit of let's have a look at the config file, at the main config file. It's a YAML file, config.yaml, and it's relatively self-explanatory. So you have a job name, you have the queue, and I just noticed something. Quickly remove that. What I'm currently doing, I just remembered that if I were to just run it like that, because I said all the directories will be on Scratch and will be put on Scratch, it would actually overwrite some of the stuff that I already have that I want to talk about later. So let's hope that this didn't do too much bad. So I'll just give it a slightly different laboratory name. Okay, so let's have a look at the configuration file again. So name, which queue, how much wall time I should use, and this is actually a pretty old value. It takes just under 1.5 hours to run a year. So in modern one is probably 1 hour 45 minutes should probably be enough. Then laboratory. This is where the actual meat of everything happens. So it's a directory. If it is a relative path, and the relative path means it doesn't start with a slash, it will be relative to this location, Scratch project user, which I think you should probably leave it as that. It's just that I have some other directories there already, so I don't want to override it. Model access. This is for Payu to know which model to run. You need that, and then, as we talked before, access comes with submodels. The UM for atmosphere, MOM for ocean, sea ice for the ice. So we have these submodels here. Each of them have another description. So so it's fairly self-explanatory. It has a name, which also is reflected in the names for the configuration files that I'll come to in a moment. What kind of model it is. So this is the UM, how many CPUs it needs, the executable to run this model, and then a list of input directories. Basically, everything in the input directories will be copied into your into your laboratory, into your work directory, and then you can use it it will run there. So you have that for the for the atmosphere, for the ocean, for the ice, and we also have one for the coupler, because that only contains the num-couple file and a few netcdf files in this input directory. So this will be distributed actually into the other work directories. Then collate, that displays the root coming out of MOM. The collate is a program that helps MOM to kind of clean up their output files. I don't really know too much about it. You probably don't need to touch it if you don't know what it means. Restart, this is where it says restart. In fact, these are where the start dumps are. For Payu runs every model as if it was a continuation run. So for the first run, because it doesn't have any restart files yet, it collects the restart dumps out of this directory. That will only happen for the first run, so you can just leave it in here. In successive runs, it will then collect the restart dumps out of the archive of what it has created before. Now here we come to the calendar. As I said before, we don't specify an end date. We have a start date, in this case year 101, month 1, days 1, and then a runtime. So each run in this configuration calculates exactly 1 year. I would leave it as that. This is for this model, for this configuration, this is the optimum time frame. Just leave it like that. And then by telling Payu how many jobs to submit, you kind of declare how much into the future you want to go. And then if you want to go further, just run Payu run again, it will automatically see, okay, the last run went until then, so the next one goes for the next year. Runs per sub is a nice workaround that was quite useful on Rajan. I haven't seen it so much on Gadi yet. We had a situation where the models would hang in the queue and not running for hours, sometimes days, and then they would run for 1.5 hours to calculate the next year, and then they would go back into the queue and be stuck in the queue for another day, and that would, of course, seriously hamper the throughput. And with this, if you increase the runs per sub, it will then kind of put several submits into a single several runs into a single submit. So if you were to replace this by 7, it would run 7 years in a single submit. Of course, you would also have to change the wall time there. I would, but on Gadi, I don't see it as an issue. Just leave it like that. Stack size unlimited, leave that. Queue sub flags. Now, the important queue sub flags, so the storage and all of that, Payu figures that out on itself. But if you want to have some sort of additional ones, in this case here, that all output files should be group readable, that can be done, that you can just add these flags down here. And that is the main configuration file. Actually, I did make changes, but doesn't matter. See where I'm at. Yeah, I like to just ask for questions now. So are there any questions so far for the configuration file? Because that's I think that's easier than to just wait till the end of the lesson. If you have something burning on your mind right now, just ask it either in the chat or just unmute yourself and ask it in person. Nothing. Nothing at all. Okay, so let's go to the submodules. If you look, if you go with the tree again, you can see it has set up the system. So it has now created a work subdirectory that is just a link to a directory on Scratch. So this is where the files will be during the run. But you can see that there is a configuration file for the atmosphere, for the coupler, ice, and ocean. And these are the same names that were given to the submodel models in the configuration file. Yeah, the most important one or the most complex one is obviously the atmosphere. So let's go into this one. So if you've worked with the UM before, you will recognize most of these files. In its history, /c, and so on. Now this is a little bit misleading because I mean the /c is probably /c is important because it configures what files it should output. But the main files that you need to look for here is the name lists. And this is one file that contains all the name lists for all the configuration files. So anything that is in here, for example, all of these name lists, they are also in this one name lists file. So so you can see here, this is these are all the name lists that you need to configure the unified model, so the UM. So if you want to change, for example, the mass mixing ratio, so in the pre-industrial run, these are just fixed values. You just set these values, you update these values here, and then that would automatically make these new values available to the UM. At the end, if you have changing, you would have changing values. I'll show you later how that is done. You would change this to true, and then you would add arrays for that. So, and the other important file is this um.env.py. You can see it's a Python script, and this the UM uses quite a lot of environment variables to run, and these are the variables that are set by the Payu before it runs. So you have an A start file, and you have it gives you the name of all the ancillary files. You will see this input quite a bit at the beginning. This always refers back to any of the input files from the config file. So as I said before, kind of everything that is in any of these input directories that you configured in the main config file, they get simply all put together into the work directory, and that refers to this input here. There is also a work path here. Not 100% sure what that means, but it's just a different directory. So, but most of these you will use this input directory. It's not 100% automatic. So I said before, in the config file, you tell it how many CPUs to use, for example, for the UM. But then in here, you also have to tell the UM itself, not only the decomposition of the CPUs, but also you have to repeat this line here. So if for some reason you wanted to change the number of CPUs for the UM, you would have to do it both in the Payu configuration file and here in the UM vars.
Holger, there's just a question in the chat about whether the model components run sequentially.
No, they are linked with the OASIS coupler towards each other, so they need to run concurrently on different different nodes or in different CPUs, but they are talking to each other every so often, so they cannot run in sequence. Does this answer your question?
Luis, if you want to ask a further question, just unmute yourself and ask further. Otherwise, that would be okay.
Yeah. Thank you. For. Can you hear me?
Yes.
That's good.
Yeah. So yeah. I was asking because you have said that it runs around 1 year. 1 year in 1.5 hours, which makes like a total of 16 years per day. So I was wondering if there is a way to change the components, how they run to make it faster, or that's the fastest it can go, like sometimes there's a way to do, like, I think it's called load balancing or something like that.
So we're not doing a lot of automatic load balancing. This is we've tested for various configurations, and we figured out that this was a good compromise. The thing is, with all parallel computing, you will always have the situation where at first you have, if you think about it this way. If I told you, well, one builder can build a wall in 1 day, how long does it take 100 builders to build the same wall? And you will immediately realize it will not be 100th of a day, because they will get into each other's way more often than not. So you have several things that you want to keep track of. You will have the how quickly do you get how quick a turnaround do you get? So how many years can you calculate in a day? But then also, if you just throw more CPUs at it, it might get a little bit faster, but you're also paying far more for more CPUs. So we figured that this is a nice compromise, and it takes about 1.5 hours. I don't quite know where Chloe got this 16 hours per day, maybe 16 years per day, but it is pretty close. So, so 1.5 hours per year.
Yes, I can just weigh in there as well, Holger, if you want me to. So yes, the 1.5 hours runtime and the 16 years per day assumes that you have no waiting time in the queue. So this is the maximum you kind of can get if the model doesn't spend any time in the queue. In terms of resources, the current setup is kind of optimal for this model. You can, as Holger said, you can throw more resources at the individual components and you might get some speed up, but you also will use a lot more resources. So it's always a balance between the actual costs and the speed up you get. And then you also have to have in mind, because things are running in parallel, that if you make one component faster, it might still wait for another component because that one still runs slower. So it's a bit of work required to get the number of processes assigned correctly.
Okay, great. Thank you.
Okay, no worries. So let's go back to this. So as I said before, the most important files in here are the name list, the UMN, and probably the -c file.
Sorry, Holger. Sorry, one more thing about the UMN. What is exactly the input? Because I didn't understand that. Like the input, I don't know if that was a folder or like the name of the path.
Yeah. If I go back to the main configuration file, you can see here for the atmosphere, you can see that it has here under input, it has 2 directories. So let's have a look at this. At this directory, and then you should see all of the, okay, so this has already created quite a lot of output, but
oh, there's input is here. Okay, yeah.
So you can see that all of these files get copied into this input directory here.
All right.
And that is what the input in the UMN refers to.
All right, thank you.
Okay, so it is actually a real path, well, real path in some sense, but of course you can see that all of these are simply links to the directories, to the previous directories.
Yeah.
Okay.
Yeah. Perfect. Thank you.
So now the atmosphere is the most complex part of this. But let's have a quick look at the ocean. Again, you just have a few configuration files for the ocean. These are under version control as well, and you basically have this one file that contains lots of name lists that you need for the ocean, and you need to know what these means from your knowledge about the MOM itself. So or about this thing as well. For the coupler. You see there's just this one numcouple file, and that is just the normal ACCESS numcouple file. It does get, if you look at this, it does get slightly modified. Everything gets slightly modified by Payu as well. So a few things get updated, for example, the year or something like that. So if I look at the difference from numcouple from the original file and the and from the working directory. So Can I get a little bit more? So yeah. So for example, here you see that that Payu was smart enough to notice that the runtime was incorrect. So it has updated the runtime. It's also, for example, what I said before. In the name list file, there's a you can see that a few things have changed here. They have been updated by Payu, but you cannot trust everything you do. It's still, Payu is still a work in progress, and feel free to contact us on the CMS help desk if you run into any issues. Fundamentally, it is still, so the project that I started before is still running, but just in terms of what we can expect, let's have a look at a run that I did earlier. So this is how the directory will look after a few runs. In this case, three runs. So the work directory has been deleted again because it's not running at the moment. But I now have this archive, and let's see. You can see that this is a link again to Scratch. Interesting. So it has, for each run, it has these output and restart directories. And let's first go to the restart directory. So you can see that for each of the submodules in this atmosphere, coupler, ice, and ocean, I think it's there the A to I and so on. No, there are actually quite a few things in there. Interesting. So for example, for the atmosphere, it has a restart dump and a little YAML file that reminds itself what the year was. And when you start Payu run again, it will look for the latest restart directory, and then we'll use that as the start for the next run. And similarly, for the output, you again have well, the log files, but you also have the output files for the different subcomponents. So if I go here in the atmosphere, here you will have all the different output files for the UM. They're called AIIHCA for the UM. I think that is because the configuration that we basically, most of what we did is we used the UI to generate output files, and then to generate the configuration files, and then shank them into first the scripts, and then later into Payu, and that's kind of where they were. So disregard this AIIHC. That's just what it comes with. But then you have here, these are actually restart dumps, but here these are the output files. So for April, January, February, and so on. And similarly, for the ocean, you will have the same thing. So you have not 100% sure where about how the ocean output goes, but there are the netcdf file, which I'm fairly certain is the output of the ocean. Any questions about that?
Yeah, sorry. Can you control the frequency of the output, like say monthly, daily, and also the variables that it outputs?
That would be part of the of the submodule configuration. And in this case, for the atmosphere, for example, it's this -c file. It's a little bit cryptic how this comes along. What I would recommend is you just go to, you just start a if you want to change some about, so these are the most important things anyway, these are the CMIP 6, all these CMIP 6 fields, is that correct, Thilo?
Yes, that is correct. I can give a very quick summary if you want me to, Holger. So, so the -c file is basically where you define your output. So you have a number of columns here, IMOD, ISEC, and item. This is just to identify a variable. So model, sections, and an item. Then you have 3 further columns, which are the domain, time, and usage. And these are defined at the end of this table. So there are various domains, so you can output at all levels. You can output a diagnostic, you can output at the tile level, for example, for cable output. So you can really specify what kind of output you want. The time lets you define if you want monthly, daily, or time step output, if you want a mean output or the current output. Yeah, Holger's just going down to the relevant section. So for example, here you have a daily mean, daily output, dump mean, and so on, 6 hourly output, 6 hourly, and so on. And the number that's given in the column basically refers to the order that various configurations are listed here. Yeah, it's just a very, anyway, there is probably a more comprehensive guide somewhere else. There's also a website where you can have a look what output corresponds to what variable and what the section item number is.
So what I would probably do if I needed a new field is I'd probably go on ACCESS-Dev, start the UMUI, and then configure my search for 7.3 job, configure the stash outputs as I want them, then press the save and process. And in this process, you will, by pressing this process, it will generate a -c file. And then I'd probably just copy that -c file over to this job. That's probably what I would do. But you will also find that you should probably have a look at all the fields that are already in there, because I would assume that most of the output that you need is there in some way, shape, or form.
Oh, can I ask another question about that? This is Ariane.
Yeah.
So when I was running ACCESS 1.0, I didn't need very many atmospheric variables. I mostly was interested in the ocean and the sea ice. And in the MOM and sea ice name list, I was able to like control what was output fairly reasonably. They were like, you could figure it out, but I found the -c files really hard to understand. And so I didn't need as many variables as it was outputting, and it would output them, and then I'd have to go through and delete them to save space. And that seems like not really the the best way to do it. Would it be possible for like a pretty basic like /c list to be put together, so people who don't need lots of variables just get like very basic variables, like, you know, surface pressure and surface winds and temperature, say, or you know, or something that people could build with that didn't
it's always possible. Basically, you would need to convince Claire to tell me to do that, because it is work to put this together.
Yeah, of course.
So if I get told to do it, then I can find time. But if I don't get told to do it, then I might have to do something else. So you can always I forget. Are you still with the center, or are you?
Yeah, I am.
Yeah, still with the center. You can always put an email to our help desk, and then that way Claire can see what has to be done, and she will tell me to do that. Otherwise, yeah, there's always these. I always have this thing in my head, floating around in my head, to build a small Python program to generate these -c files. For a computer, it isn't actually that hard, but for a human, it's really hard to understand. So I don't know. That would be a lot of work. So I would, in order for me to actually get the time to do that, I would probably need a little bit of pressure from the researchers that they need it. Otherwise, well, you can always. I'll show you something else, something that you can do in a moment. Let's keep going, because there's one more thing that I'd like to point out about Payu, and we have only about 10 minutes or so left. So there's something else that you can also do, and let's have a look at a far more convoluted task. So this is now a pre-industrial, not a pre-industrial. This is a paleoclimate run. This is a last millennium run. So this was a run that's meant to model about 1300 years. So there are a few things different. Let's first have a look at the config file. And you can see here that it has actually, that is already different. So we have here, you can have these user scripts. These user scripts, basically what they do is that you can, do I have this open? Yeah. So this is a little bit of the documentation about Payu. So you can go to payu.org/payu/docs source, and maybe I'll send the link out later. But you can have these user scripts in here, post-processing. Yes, user scripts that are basically, you can basically, in the steps between initializing, setting up, running, and archiving a run, you can basically insert your own scripts that should run in between. So you might have something in there that that automatically then drops the fields that you don't need from the model. Alternatively, what we're currently doing, what I was hoping to have finished by this session, but it hasn't yet, is to have an automatic conversion from the format to netcdf. That would also use this user scripts. So so you can see that we've inserted 2 of these user scripts. The first for the initialization. So the model set to first spin up, keeping it at the year 850 until the model has stabilized. So we have here an init script that basically at the end of every run resets the year to the year 850. And then there's another one that updates the land use because the files were simply getting too large to do that. And also, if you look at the atmosphere, you can see that you can see here that the concentrations, of course, they had to be prescribed, the greenhouse gas concentrations for this last millennium run. We have these, we've created these huge name list files in here to basically manually set the concentration of the various greenhouse gases. And at the end, this one had to be set to true because that is what means that these are variable. Otherwise, they would simply set the fixed ones. So there are certain things you can do. We have a few of the ESM models. We have a few of the ESM models ported to Payu. Not all of them, mainly because CSIRO has done most of the runs on Rygen with the old scripted versions, and so we didn't it takes a little bit of work to convert to bring them up to convert them into Payu. So we have the pre-industrial, which was mostly working with. We have the historical, and then we have the mid-Holocene, last interglacial, and last millennium. These are experiments that some of our researchers wanted, and that's what we have ported. And I think we have 5 more minutes for some questions, and I think then it's time for the break.
Can I ask a question?
Yeah, sure.
About UM. So let's say I already ran a few UM experiments. So said if I wanted to run the same experiment but using the couple model, could I just copy my entire kind of folder or all the files that, like for example, the name list, stashes, and everything of my run with the UM in the atmospheric folder of the couple model? And would it work or not?
It's a little bit more.
Okay.
Because there are a few things that would probably be different. The first thing that would be different is the fact that you now have a coupled model. So there are a few options that are different between a coupled model and a standalone model. And then also you would basically have to merge all the various name list files that you get from the UMUI. You would have to merge them all, but that can be done with a simple text editor or even just a cat into this name list, into this one name lists file.
Okay.
And then you would also have to look at all the to make sure that you get the correct ancillary files and everything else. It is more than just dumping all the configuration files from there and here and hoping that everything works together. That also will be probably a slightly bigger job. If you need that, it might be a good idea to contact the help desk. Are you a CLEX member or are you?
Yes. Yeah.
Yeah, that might be something to contact the help desk for how to run it, how to configure it. Yeah,
maybe I'll see in the future. Maybe I'll need to run it, and I'll definitely ask for help.
Okay.
Yeah, thank you.
For those who were in the ESM breakout room, what I was conducting in the main session was I was running through a tutorial that's available on the ACCESS Training Confluence page that I sent out. It's essentially a tutorial running through how to use the ACCESS-CM2 suites. I've almost finished it, and I'm up to the very last part here. as you can see on my screen, I'm up to part 7, model output data. That is going to be applicable to the ESM as well as the CM2. Currently, with the Payu setups, they don't quite put everything in the exact same format, file directory structure that the CM2 does, nor does it currently convert the files to netcdf. However, we are working on including that into the scripts, and we're hoping to get that loaded up into the Payu versions on GitHub next week sometime, where it will automatically, at the end of each cycle, do the same work that the CM2 does. It'll copy everything over to this archive on Scratch, on Gadi, and it will convert files into netcdf. I'll talk about the files a little bit here as well, and just some general sort of stuff. Nothing too in depth, but I did want to just sort of go through this sort of final stage of running the model. Currently the CM2, very soon, hopefully the ESM and the Payu version as well. So I'm going to get started up on that too. So if you're following along, that's what we're up to, part 7 on here. I don't know if anyone's actually following along with this tutorial, but in case you are. In the last session, I ran some models, some CM2 models. I ran them for just a couple of months. I had some pre-prepared ones. I think the ones that I was set up and ran in the last session are still going. Fortunately, I ran one last night with the exact same settings, and it finished. It ran two months worth, 2 cycles, and it copied all of the history and the restart information onto Scratch. So it copies it onto GData, and it copies it onto Scratch under the project from which you have run your project, your model, under your ID, and then in a directory called archive, and then obviously the suite name. The suite name, I'm not sure how it's going to work with the Payu, but for the CM2, it's the suite name given by rows when you create a suite. So when we come into here, we've got two directories, history and restart. We're going to start with the restart, and then we'll look at history in a little bit. So with the restart, what the model does is I'm not sure if it's every month or it's only every restart. So if you have your like a 6-month restart, I think it might only do it every 6 months. But anyway, every cycle, the model will dump out all of the prognostic fields from each of the components into a suite of files, a range of files that it can then source in order to spin up a new experiment, or for whatever purpose you might need. If you need to go back and rerun the model for a particular time, and you've got the restart files, you can go back and start it from any particular time you want and just get it going from there. That's what the restarts are. So I'm going to show you what the restart directory looks like. So in the restarts, we've got 4 sections, 4 main components of the model. We've got the atmosphere component, the coupler, which is the OASIS 3 coupler. We've got ice, the sea ice, and ocean for the MUM. I'm going to show you what each of these look like. For the atmosphere, for the it produces 2 main restart files for each cycle, each month that it dumps restart files. This one here, the large file here, this .da file is essentially a snapshot of the climate in the as it was at the point where it was dumped out, for which is the start of February in 1850, which is where we left it off. I've also got my model running for 2 months, and so we've got one for the start of the 3rd month, which hasn't been modeled, but that's how it's dumped out to be at the beginning of March. The numbers used are slightly different. Sometimes the restart files will have dates of the previous month, and so this is 1850. This file here is 1850, the 31st of January, and it lines up with this dump file. So you get a .da file and a .xhist file. In the coupler, the restart files in the coupler, these are netcdf files, which are pretty much have a snapshot of what was being transferred at each point between the different components of the model. The coupler essentially just it passes variable information and prognostic fields between the different models and navigates passing information between the components. And then the restart files for it are a snapshot of that. So this is the ocean atmosphere into the sea ice, ice back into the atmosphere, and then ocean into the sea ice, which are the three main couples that are done. At the ESM works very, very similar, and so you'll have very similar stuff to this in the ESM into all of this. For the ice, we have 3 restart files for each dump. This is the I couldn't really tell you what the difference between that. I think this is the daily information. This is some monthly information, and then this is some sort of separate information required for the restart. So you've got 3 files for each dump in the ice. For the ocean, it produces the ACCESS-CM2, the suites the way they are, it produces 1 tar file. What it actually produces is, I think I can show this. Inside each tar file, 16 files that are produced by MOM. So MOM dumps out 16 different restart files for various aspects of the model itself. And so you'll need one of every one of these. So make sure you don't sort of lose them, I guess. That's a convenient thing about the CM2 suites is that we'll tar them up. I might even see if I can include that into the Payu post-processing scripts as well. The tar is really helpful because then you make sure that everything's together and you're not losing any small components that might prevent you from actually performing a restart if you need one. The restart files for the these ones here, they're the files. So the UM uses its own proprietary file format called PP files, that we call them fields files, PP files, a few different names that we've got for them. These are a proprietary file format that you can't just use with netcdf. They're a tad restrictive, but we do have ways to use them. As mentioned in my tutorial, there's a package called a Python library called Iris. We use that pretty regularly. There's a few different packages that are able to interact with the files. We use Iris to do our netcdf conversions within the suite. And so that's something that's very useful. It can do a lot of plotting. It communicates natively with the files, but also with netcdf files. I think it can do grid files as well. It's great for plotting. It's specifically designed for climate data. It's really, really useful. What we're going to use today to have a look at these restart files is a code called xconv. It's helpful for having a really quick look at some of the files. You can't do much, a huge amount of manipulation or anything with them, but they can convert into netcdf as well. So I'm going to load that up. I have in my tutorial here a description of that. So I'm going to source the binary for xconv straight out of the ACCESS projects. And I'm going to just load up xconv so you can see some of that and have a look at one of the restart files. We've got restart, the atmosphere restart. This is the file name, and we'll do the first atmosphere dump of that. Great. Okay, just give me 1 second. I'm having issues with that. Let me try this real quick again. Otherwise, I might have to skip this step. Oh, okay. So I'm just going to load some of my aliases here in case that's what's preventing me. No, okay, that doesn't look great. Okay, I'm going to skip xconv for now because I did not get this message when I was testing this earlier today. But essentially what xconv does is it lets you inspect the data. You can have a look at the actual data itself pretty easily if you want to. You can do some basic plotting with it. Nothing scientific, more just basic inspecting. So you can easily plot any of the data that's in the restart files which contain everything that's in the model essentially. You can also save to netcdf files. One by one, it's a very tedious process if you wanted to convert a whole bunch of files into netcdf, but it does have that facility. You can even select singular fields if you wanted to just pull out certain fields, if you wanted just a couple of them, surface temperature, whatever you want, and save those to netcdf and just get like a small netcdf file with just whatever fields you want from the restart files. If you do go back into the tutorial, you can give that a go. I've clearly got a terminal issue here, so I've never seen this before. So I'm going to do some debugging later on. Let's have I'll skip over that now and move on, and we're going to look at the history data here. I'm going to talk just briefly about what that looks like. So we've got history, we've got the same for directories under history as we did in the restarts, atmosphere, the coupler, sea ice, and the ocean. And for each of them, we're going to have a quick look at the files. So under the atmosphere, what we've got is I've got a range of files here. I've got January, February files. What I'm going to do to make this slightly more obvious, I'm going to type 1850 and just have a look up 1850 Jan. So just for January, I've got 8 files here. 4 of these are files, the ones with the .nc at the end. These are the pp files. They're a bit rawer, they take up a little bit more space. In the long term, we're not keeping them. We're storing just the converted NC files. You can actually turn off in the suite itself. You can tell it to not save these and just save the NC files. For a sort of, you never know when things are going to fail. So I think only if you're confident that everything's running smoothly. And then for each of these, it's created an NC version of it. So it's used Iris to read in all the data from the file and create an netcdf file. For the CM2, the naming convention here is important to note. .p7 here is 6 hourly or 3 hourly. I have to double check that. I actually have a feeling that's 3 hourly. So it's .p7, we've got 3 hourly files. They're quite large because 3 hour, you've got twice as much data as 6 hourly, which is here. We've got P8. That's where my surface temperature that I added will be included in. We've got PD, which is the daily data, and then we've got PM, which is the average monthly data. This with the ESM, it's slightly different convention in naming of these, but upon inspection, it would be pretty easy to figure out. Just a matter of having a look at the documentation when we sort of put it out there. I'm going to have a look at one of these. Now, with the modules, I had just loaded up a whole bunch of modules before, but what we want to do is you want to have a netcdf module loaded. And so you can, so we can go module load netcdf for something really basic. And I'll just unload that. We also have a range of, we've also got some packages, some Conda packages that are under CLEX, under CLEX's HH5 project. These kind of packages are designed to include a lot of Python libraries that are really useful, SciPy and Iris and all of that. It includes some netcdf stuff. You can easily load in a lot of netcdf tools. I'm not going to talk too much about all of this because I don't really have the time and it's not really the focus. So I just wanted to mention that if you want to refer to this, I've got some advice on how to load up some of those great Conda modules from CLEX. It's what I did. I've got earlier. I've got this running in the background. It's called the Analysis 3, so it's a Python 3 Conda environment. Includes not everything you might need, but a lot. I load it pretty much all the time. So I'm going to have a look into history data. I'm going to have a look at one of these files. I'm going to use NC-dump to have a look at the information, and I'm going to check on the C flag, so just loading up the header and the coordinate data, not all of the data, because netcdf dump will show you everything, and we don't need to see everything. I'm going to have a look at this. I'm going to pipe it into less, because that's the way I like to work. I'm going to have a look. This is our, these are our output files from the UM. Just check out that numbering. We've got the dimensions at the top. These dimensions, we've got model theta level and model row level. These are full model levels, and these are half model levels, halfway up. We've got a few different pseudo levels. These pseudo levels are related to 5 pseudo levels. This one is the CICE. CICE has 5 levels in the model. This one here is soil depth. Soil depth in a cable has 6 depths. This one here is 17, and it's cable tiles. So there's a lot of different cable tiles. These are essentially pseudo levels containing different various information on a particular cell in the land in cable. And then these also applies to cable, which is PFTs, which are plant functional types, a different way to store sort of similar information from cable. We've obviously got pressure levels here in 19. We've got another depth here that we use for some other stuff. One of these as well, I can't remember exactly which one it is. It might be this one. I've got this listed in my tutorial. Is also related to the optical depths in the aerosol scheme at different wavelengths. So getting your head around which one of these might be applicable to you is a good start. Going to into the variables. Variables like this, you know, these are coordinate information from time. These are all copied from out here with more metadata. I'm just going to skip down a little bit. Get down to sort of the fleshy part of the model output, where we've got fields like this. This is the stash information. As in the stash requests, when you loaded them up, I loaded up a surface temperature, which was section 0, and it was item number 24. We don't actually see this. I can see this here. That's this one here. So this is surface temperature after time step. So we can see the metadata given. That's the stash file name that we can see in rows, and this then is the stash code. We chose this way of naming the fields because we needed our pipeline ultimately to be robust and to be repeated, and for having fields that have conflicting names were starting to cause some headaches for post-processing pipelines, especially for CMIP6. I required things to be very specific and to make sure that each field was purposefully designated according to its stash item, which is how this is currently laid out. I know it's not very pretty, but at least in the long name here and the standard name, it still saves a lot of information. We've got the units, we've got some more details about the stash information, and some coordinate information as well. So if you're not familiar with netcdf files, I suggest you do some reading on it yourself. There's plenty of training around. I've even linked to some training in the tutorial and the training documents. And if you're not, then you can, if you've used netcdf before, then you can go ahead and this should be familiar to you. So that's nice. That's the UM output, and that's really all I'm going to talk about with the UM. Similarly, we've got mum output. Oops, not mum, it's ocean. We've got daily, monthly, and scalar outputs in the ocean. Daily and monthly are pretty self-explanatory. The scalar information are time and variable. Usually often grid information. There's a lot of useful stuff in scalar that you might need. So if you're looking for particular fields and it's something to do with especially grid volumes and things like that, I would definitely look into that. So I'm going to have a quick look into here. Just have a look at one of these monthly files. Again, very similar to our atmosphere with our dimensions, and and variables down here. The variable names in this come directly from MOM. MOM is fed by what's called a diag table, as we call it, and it's a file, essentially just a name list file, very similar to the stash file that tells MOM what outputs, what to save in the mul output, and these names are consistent with MOM, and so they should be exactly the same between ASM and CM2. Same with these stash items, the format of the fields is the same. And then, of course, at the very last, we've got CIS. There's no history files from the coupler. It produces no history files. It just creates a directory for it. I'm not 100% sure on the reason of that, but possibly some configurations do provide history data from the coupler. So that's there. Under CIS, we've also got daily and monthly here, indicated with the D and the M. That's pretty straightforward. And I'm just going to open one of these and have a quick look into it. We've got, as you would expect, all the fields that you would be able to turn on and off if you would like in the stash as well. I'm not sure how that's done in the ESM, but in general, I would rely on what it automatically provides. CIS output fields aren't a huge amount of size, so they're pretty small compared to everything else. And that is the history files. Nice and convenient. I really like this this way of presenting the data. It's nice and convenient. When you get used to it, it's very easy to navigate. That's pretty much all I've got. The only last thing I wanted to highlight was at the very end of my tutorial, I have, oops, getting messages from emails. I've got a whole bunch of links here at the very end of my training, at the end of the CM2 training. A lot of these will be applicable to people using the ESM, especially anything related to CLEX, stash information, that kind of stuff. But in general, and then I've got some IRS. In general, this applies to most of the CM2. We've got plenty of useful links here. I want to make a particular note of the CLEX help desk, the CWS help. Great resource. A lot of very well-trained people get these emails, including myself. If you do have any questions and you're working through this tutorial specifically and you have any questions about it, feel free to send a ticket to the CWS help with my name in it. Just say, hi, Chloe. I need help with the tutorial. I'm more than happy to sort of take those on. Otherwise, if you have general questions about either the ESM or the CM2, I definitely suggest using that as a resource. And that's pretty much all I've got for now. Ah, look at my timing. That's pretty great. 25 past. The last thing I wanted to mention was that I'm also going to be putting together and making available, currently is on GitHub, although it's not quite ready for common consumption, of some scripts that you could use if you wanted to copy this data somewhere else. All of the model output. One of my packages is going to be able to copy all of this, convert it take it somewhere else, do some checks on the data, compress some things, cut down the restarts, and generally do some more longer-term archiving of model runs, if that's something that you're interested in. For our purposes, we've run many experiments, and we needed a way to easily copy them from scratch onto GData, cut down the sizes and archive them a bit more long-term. And so that's what one of my script packages does. The other one is called the APP. It's called the Access Post Processor. It has been specifically designed by myself over the last 2 years. Previously, it was used for CMIP5, and the brilliant Peter Yui developed it back in 2013. I took it on in the lead up to CMIP6, and I further developed it, and it's now I'm been using it now for the better part of a year or more. post-processing all of our CM2 and ESM experiments into CMIP6 style model output files, the DRS structure and with the metadata and everything like that. It's a bit of a clunky package to use because of the requirements for CMIP6 are lengthy. However, I've been preparing a separate wrapper for the APP that is essentially a default style, something that could be run by someone who's maybe run a simulation with ESM or CM2 and wants to post-process all of this history output into something that looks like CMIP6 data, something that you might find on the ESGF on FS38. If that is something that you're interested in, I would like to know. I'll be sending out a survey probably in the later half of next week. I haven't actually prepared it yet. I'm going to send out a survey to everyone who registered for this workshop. And I'd really like some feedback onto who you are, what level you're at. Are you a PhD student? I don't know if there's anyone who might be honors or lower attending today. I know we've probably got lots of postdocs, early career researchers of other types. I'd really love to gather that information. We want to produce more training, build on this this training even more. I'd be interested in finding out if people would like this training to be run in person in the future, like potentially COVID allowing. Melbourne I can do, potentially Monash and Melbourne Uni. So I'm going to ask a whole bunch of questions in that survey. What kind of post-processing you might be interested in. If post-processing model output into CMIP6-like data is something people are interested, then I will distribute that as widely as I can as well. So we don't have a huge amount of information about the type of participants who have joined us today, all of you, because this is relatively new. We're spinning up a pretty new sort of cycle of training, beginning with our webinar back in October. We're hoping, we don't have quite the resources that NCI does. We're not going to be able to do regular training, but we do want to build on this, produce more similar training, some in-depth stuff. We want to produce some training that will go more into the models itself, some Fortran level coding of altering the codes itself, a whole bunch of different stuff that we're starting to scope out. To do so, I need information about what people actually need and what you all need. So I would really love to hear that from you. I'll send out a survey. If you get the survey, and feel free to distribute that to anyone who might also be interested in using ACCESS. Similarly, if you have any colleagues who are similarly interested in using ACCESS and they haven't come to this workshop, please pass them on to onto the training that we've prepared, because it's useful for everyone. This whole video will be on there, all of the material for anyone to refer back to, and hopefully we can build on that in the future to provide some good training for you for ACCESS. My hope is that over this next maybe year or two, we can really get a lot of you working with ACCESS and get this distributed throughout, especially CLEX, I think, the universities and whoever else might want to use it. So we're here, we're hoping to conduct more of this in the future, and that's all from me.